is the leg opposite the angle. That's 4.2. That's opposite. The adjacent leg, adjacent means next to or touching it, is this leg right here. If I write that ratio, opposite over adjacent, 4.2 over 5, I'm going to get 0.84. That's for triangle A. Triangle B is a little bigger, but it still has a 40-degree angle in it. And I'm going to write the opposite leg length over the adjacent leg length. And if you were to do that math, you would get 0.84. You'd get 0.84. And then if you went to triangle C, which is bigger still, but it still has a 40-degree angle, and you did the opposite leg, 6.7 over 8, and divided, you would get 0.84. Holy cow. So it's a special thing. If you look at your calculator, have you ever seen those buttons down there? Tan, Sin, and COS? Graphing calculator? You're going to learn about those today. Sine, cosine, tangent. We're going to do tangent today. It's a trigonometric ratio. Okay? And it helps you find the unknown leg length of any right triangle. So, we're going to write about this. In similar triangles, the ratio of the opposite leg over, I'm going to abbreviate because that's how you're going to see it, adjacent leg. In similar triangles, the ratio of the opposite leg over the adjacent leg relative to an angle stays the same. Like here, we're looking at it from the same angle in those three triangles. We're always going from the 40-degree angle. The ratio, let me see if I can get it a little brighter. The ratio of the legs in the right, this ratio of the legs in the right triangle is called the tangent ratio. This is the tangent ratio right here. The order in which the ratio written, it depends on the angle you are observing. And I'll show you what I mean. So in this diagram, I want to write the tangent of A. We just talked about that. That ratio is the opposite leg over the adjacent leg. So if I'm here at angle A, which one is the opposite leg? Which one's the opposite leg? A, right? Tangent of A would be A over the adjacent leg, which would be what? Come on. What's the adjacent leg here? B. So the tangent of A would be this leg length over this leg length, A over B. Now, if I were looking at it from this angle, B. So if I'm looking at it from this angle, the opposite leg would be what? B. Over the adjacent leg, which would be what? A. So it depends on what angle you're coming from. Opposite leg over adjacent leg. Now, you can't do it for angle C because the opposite is not a leg, is it? It's a what? Hypotenuse. So it doesn't count. We can't do it from the right angle because we're only working with the legs here. Right? Make sense? All right, in general, the tangent of an angle. I'm going to write the tangent of A is equal to the leg opposite angle A over the leg adjacent, which means next to, angle A. Now I want you to do something on here. This thing together, that is just a number, and it's a ratio. It's just a number. Usually you'll see it as a decimal. Okay, together. This part of it is an angle measure. So sometimes you'll see tangent of 40 degrees, tangent of 35 degrees, tangent of 50 degrees. Okay? And we're going to use this a little bit now. So turn the page.
What's the word, Sam?
Angle measure. So this would be 40 degrees, this could be 35 degrees, this could be 50 degrees. All right. Below, this is a special right triangle that you're familiar with, hopefully, at this point. It's a 30, 60, 90. What are the lengths of the legs? They gave us the hypotenuse. You should be able to know the length of the short leg from the hypotenuse. What is it? Using those formulas? 4. It's half. So that's 4. Remember, it's a 30, 60, 90. That's something you've learned already. So I'm going to say RQ is equal to 4. If this is 4, how long is the long leg? Using those formulas. 4 times the square root of 3. Now, okay, I'm going to use that information to write the tangent ratio for angle S. So I'm at this angle right here, angle S. And I need to write the tangent ratio. The tangent of S is equal to the opposite leg. How long is the opposite leg? 4 over the adjacent leg, which is how long? Okay. Now, that's easy to set up, but I do want you to reduce it. This fraction is the same as what? 1 over 1, correct? But since the square root of 3 is in the bottom, it's got to stay in the bottom. It doesn't go away. So you would write this as this. You could put the 1 out front too if you want. That's reduced, simplified. Okay, so that's from this angle. Now we're going to go from the tangent of R. Let's write the tangent of R. Capital, lowercase, it doesn't matter. So now I'm coming from here, this angle right here. How long is the opposite leg? 4 times the square root of 3. I need to set that over the adjacent leg, which is how long? 4. And then I'm going to reduce that fraction. This is 1 over 1, isn't it? Since this is on top, they basically just cancel each other out. And it would just be square root of 3. So again, it just depends on what angle you're looking from. Now, let's study these ratios in the trig table on page 705 and in our calculators. So open up your book to page 705. So, it says right here, use the table to approximate the following tangent ratios to 4 decimal places. The tangent of 30 degrees. So you go here to your table. The tangent of 30 degrees is what amount? 0.5774. Okay, you do 40 and you do 74. Find the tangent of 40 and find the tangent of 74. Push mode, and you see about 3 lines down, it's degree. See, so you arrow over and push enter. Now go back and try it again. Tangent of 30. And there it is. If you want it to work with degrees, you got to tell it. Work with degrees. Okay? Make sense? Okay, so it's going to be the same in the calculator. We can just write this down. They're the same button, the same. If you want to try them, you can. But the numbers are all programmed in there. All those ratios are programmed in there. So far, maybe you're thinking, yeah, so what? Well, it kind of helps us figure out side lengths. Let's do it. Find the tangent for each acute angle in the triangle below. Write each ratio as a reduced fraction. Okay, so I'm going to do P. The tangent of P. Okay, so I go the opposite, which is 6, over the adjacent, which is 8. Opposite side length over adjacent leg length, which is 8. Reduce that fraction to 3/4. And what is it as a decimal? I found the tangent, the ratio there. You know what's super cool about this? I don't know this angle measure, do I? But I know the ratio. Could I find the angle measure from my table? Oh, look at 0.75 is right here. That's the tangent ratio of 37 degrees. So that's about 37 degrees. Sweet. Yes, it is. Okay, let's do K. The tangent of K. So the tangent of K is the opposite, which is 8, over the adjacent, which is 6. Don't use 10. They threw it in there to throw you a curveball. It's the hypotenuse. We don't use it here. Okay? So we reduce that, and that's 4 over 3, which is 1.3 repeating. And I know you really want to know how big that is, so you can look at the table if you want. So, it's about what? Yeah, say 53 or 54, somewhere in there. Okay. All right, so now we're going to use it differently. Use the tangent ratio to find the length of the leg in the triangles. So this is slightly different here. They gave us the angle measure, and we're going to use the ratio to find out what this leg length is. So you set it up like this. You just do the tangent of 22 degrees. They gave me the angle measure. Equals the opposite, which is x over 10. Now remember, this is just a number. It's a ratio. Where can you get what that number is? On your calculator or on the table. Okay, so what's the tangent of 22? Let's see. Tangent of 22 is 0.404. I'm just going to use 3 places. Oh, it's not on degree? Okay, hold on. I'll fix it. Okay, but you look at that and you say, yeah, that's yucky. It's really not. Look at, it's beautiful. If we put it over 1, how can I solve it? Cross multiply. If I put that number over 1, I can cross multiply.
Okay, how did you get 0.4?
Off of my, this is just a ratio, remember, tangent of 22. So I went to my calculator, pushed in tangent of 22, and found out what that was. So now I can cross multiply. 0.404 times 10 equals x, and x would be 40.4. 40.4. Sweet? Okay. Let's do this one because it's slightly different. They gave me this angle measure, so that means I can set it up as the tangent of 40 degrees equals the opposite leg, which is 10 over x, over the adjacent. We've worked with 40 degrees already. Does anybody remember what the number is? Tangent of 40 degrees? We've done it a couple times here today. It's 0.83. Yeah, it is. Equals 10 over x. Yes, Ian.
Yeah.
Oh, I'm sorry. Thank you. 4.04. You're right. Thank you very much. Okay. So back to here. How do you solve it at this point? Yeah, you put it over 1, and then you cross multiply. So it's kind of messy here. So you do 0.8391x equals 10. I know it's small, sorry. And then you divide both sides by 0.8391. And x equals what? It does? 10 divided by 0.8391. It should be 11.92. No, we're going to do just a few on the back side. Oh my goodness. Yes.
So many.
We're not doing all of these. Don't panic. What?
I
Yeah. Cross this one off. We're not doing that one. And we're not doing the last one. So we have 3 problems to do.
32 minutes.
Okay? All right. Use the tangent ratio to find x. Verify your answers by checking against previous methods. Oh, look, it's 60 degrees. That means this is 30, 60, 90. So you know already what the short leg is. How long is the short leg? 20. X equals 20. It's short. Because you take this and divide it by square root of 3. Let's use the tangent ratio to see if it's true. So the tangent of 60 degrees is equal to 20 times the square root of 3 over the adjacent angle, which is x. Adjacent leg, which is x. Now, find the tangent of 60 degrees on your calculator. What is it?
1.732.
Thank you. Equals 20 times the square root of 3 over x. I put this over 1. I cross multiply. 20 times the square root of 3. And then I divide both sides by 1.732. Those cancel out. And x equals this. You just throw it on the calculator. It's multiply, and you end up getting x equals 20.0006. Oh, look. It works. 2 more. So this, if you're thinking about, like there used to be a motorcycle shop in Dexter, and my husband rebuilt a motorcycle. I used to go down there with him occasionally. I wasn't that into it. And I'm like, how much do you guys use geometry in here? And he goes, we use it all the time, especially trig ratios. Or if you're going to be a contractor, an architect, a landscaper, going to build anything in your house, it's really handy to know how to do this. I actually used it when I was helping a friend of mine. Believe it or not, I did. I know, math geek, but they're like, can you tell me how high this has to be if we know this angle measure? I'm like, well, yeah, I can use a trig ratio. You just never know. So, first of all, use the tangent ratio to find the height of the tree. I want to label this angle because you're going to see this term. It's the angle of elevation. Sometimes it's called the angle of elevation. So I can find out how tall this tree is if I know the angle of elevation and how far I am from the tree. So I need the tangent ratio because I'm using opposite over adjacent. The tangent of 55 degrees
1.4281
equals h over 45. Opposite over adjacent. So what was it? 1.428. I'll just go that far. H over 45. Now how do I solve this? Put a 1 under it. Yep. And cross multiply. 1.428 times 45 equals h. And so the height of the tree is about 64.26 feet. Pretty nifty. If you know that angle, you can measure any tree. Because you really want to.
Yes, I would love to do that. Let's go take a field trip.
Okay, last problem here. Find x and y. This is one of those, let's stand back and take a look at it. I see 40 degrees here. I see 30 degrees here. Oh, wait. If I cover this up, do I know what x is? Yes, I do, because it's a 30, 60, 90. And I know the hypotenuse. So how long is the short leg?
110 squared. No, it's half. It's 955.
55. It's half. Right there. Hypotenuse is 2 times the short leg. Okay? Oh. Okay, well, I know that leg. Now I can find y by using what ratio? Opposite leg, adjacent leg. What am I going to use? The tangent of 40 degrees equals 55 over y. Oh, there's that 40 degrees again.
0.84.
It's 0.8391 equals 55 over y. Put this over 1, cross multiply, you know the drill now. 0.8391y equals 55. Divide. I know you really want to know how long y is here. You ready?
I don't care.
Y is 65.546. So that's tangent ratio. You know trig now.
So cool.
It's
Yeah.
trig.